So I didn't really have a name for this one, so I'm just calling this one a mixed bag. They gave you a function f of x, and the first thing they asked you for was the slope of a line tangent to the graph at x equals 3. Just means it's asking you for f prime of 3. So if f of x equals, I'm going to rewrite this as 3 times 2x squared minus 7x plus 5 to the negative first, so I can use the chain rule and not the quotient rule. F prime of x is negative 3 times 2x squared minus 7x plus 5 to the negative second. That's the derivative of anything to the negative first times the derivative of anything is times 4x minus 7. So f prime of x equals negative 3 times 4x minus 7 over 2x squared minus 7x plus 5 to the second. So then I'm going to find my derivative at 3. F prime of 3 is negative 3 times 12 minus 7 over 2 times 9 minus 21 plus 5 squared, which is negative 15 over 18 minus 21 plus 5. 18 and 5 is 23 minus 21. So 18 is 2. 2 squared is 4. Having a brain fart. There you go. Find the x coordinate of each critical point between 1 and 2.5, where 1 and 2.5 are not included. Classify that critical point as a relative min, relative max, or neither. Justify your answer. So the first thing I did is take and set the top and the bottom equal to 0 and solve. So negative 3 times 4x minus 7 equals 0. So that's going to give me x equals positive 7 over 4. 7 over 4 is 1.75, which is in between 1 and 2.5. When I set the bottom equal to 0 and solve, square root, that goes away. I'm going to factor this as 2x and x, 5 and 1, negative, negative, 2x squared, 5, yes. So x equals 5 over 2, and x equals 1. So these are those endpoints that are not included. So I only have to worry about 7 over 4. Remember, AP is not going to read your sign line. I like to write them anyway. So here's 7 over 4, and here's f prime of x. So I'm going to find f prime. I'm going to do 6 over 4, which is 1.5, and 8 over 4, which is 2, which is going to land in that interval. Now, looking at my derivative, what do I know about the bottom? Anything squared is going to be a positive. So I know the bottoms are going to be positive. So I only have to worry about what's going to be the sign of the top. So if I plug in 6/4, that's going to give me 6 minus 1 is, minus 7 is a negative times a negative is a positive. And then if I plug in 8 minus 7 is a a positive times a negative is a negative. So that means f of x goes from increasing to decreasing. So that means x equals 7/4 is a relative maximum because f prime of x changes from positive to negative. At that point. Okay. So this one's positive, that one's negative. So remember, when you're justifying a relative max or a min, you can use the first derivatives test or the second derivatives test. I used the first derivatives test because I had a first derivative and I didn't want to have to find a second derivative. It had been extra work. Using the identity, evaluate the integral, or show that it diverges. So they already did the partial fraction decomp for me. So they're saying that this is equal to 2 over this and negative 1 over this. So the first thing I'm going to do is set this up as an improper integral. Limit as r approaches infinity, the integral from 5 to r of 2 over 2x minus 5 minus 1 over x minus 1 dx equals the limit as r approaches infinity of 2 is going to come along for the ride. This is 1 over a linear, so the antiderivative of 1 over u is ln of 2x minus 5 divided by the derivative of that linear on the inside minus ln of x minus 1 from 5 to r. Now I'm going to plug in my upper limit minus my lower limit. So this is the limit as r approaches infinity of ln of 2r minus 5 minus the ln of r minus 1 minus the ln of 10 minus 5 is 5 plus the ln of 4. Now, I'm going to go ahead and condense using my properties of ln. So this is going to be the limit as r approaches infinity of ln of 2r minus 5 over r minus 1 plus ln of 4 over 5. The negative goes in the bottom, the negative goes in the bottom. When I take this limit, this is equal to the leading coefficients because I'm equal on top and bottom. So this just becomes ln of 2 plus ln of 4/5. And then I can multiply and condense here, and this is ln of 8/5. Now, part D says determine whether the series from n equals 5 to infinity of 3 over 2x squared minus 7x plus 5 converges or diverges, and state the conditions or test used to determine it. Well, since I just found the integral in part C, I'm going to use the integral test. So 3 over 2n squared, let's call that 2x squared minus 7x plus 5 is positive, decreasing, and continuous. From 5 to infinity, and the integral from 5 to infinity of 3 over 2x squared minus 7x plus 5 equals ln of 8/5. Therefore, the summation from n equals 5 to infinity of 3 over 2n squared minus 7n plus 5 converges by the integral test. I could also use the limit comparison by comparing it to my b of n as 1 over n squared and find the limit of a of n over b of n, and then it does whatever b of n does. And because b of n would be 1 over n squared converges by p series, and this one would also converge. So I could have done that, but again, I'd already found the integral here, so might as well use the integral test. Thanks.